Hello everyone, wish you a very good morning to all of you. Here I am your science teacher. Now get ready for your science class. As you know that we have recently completed chapter 10, that is motion. So from this chapter we got different information about motion, types of motion, their examples, their features. Now today we are going to solve some uh, exercises from this chapter. You can see the page, some questions been written. So look at the first one. So today we are going to solve all these worksheets, okay? Classify the following as motion along a straight line, circular or oscillatory motion. So just classify all these motions, the examples you can see, into three categories. Straight means curvilinear motion, linear motion, circular motion and oscillatory motion. You know that the motion or the movement of any object along a straight line is called linear motion. Circular motion means the motion along a curved line, a curved path. And oscillatory motion, small to and fro movement of any object is oscillation. Okay, let's read the first one. See the example. Motion of your hand while running. When we run, then our hand shows a specific kind of motion. So which kind of motion is this? That is oscillatory motion. Okay, so here your answer should be oscillatory motion. Okay, just write oscillatory motion. Next, 2. Motion of a horse pulling a cart on a straight road. That is a linear motion. So the motion along a straight line, that is called linear motion. So just mention linear motion as the answer. Next, 3. Motion of a child in merry-go-round. That is a circular motion. The answer of third question will be circular motion. Now 4. Motion of a child on a seesaw, that is oscillatory. 5. Motion of a hammer. Motion of the hammer of an electric bell. This is also an oscillatory motion. It is a oscillation. The motion is a oscillatory motion. So 4 and 5 both are oscillatory motions. Now 6. Motion of a train on a straight bridge. You know that. That will be the linear motion. So you got your answer. Now 2. Which of the following are not correct? Not correct. So just read the statements. First read the statements and then identify all the statements. Just categorize all the statements into true or false, or you can write correct or incorrect on the right of each statement. The basic unit of time is second. Yes, the basic unit of time is second. As I told you before, that different methods are available: MKS, CGS and FPS. These three methods are widely used to measure different things. So the SI unit or the standard unit means, you know, that MKS method. So MKS is also known as SI method, international unit system. So here in all these methods you will get second as the unit of time. So second is the basic unit. Okay, this is true, this is correct. You can write true or correct or C. Next, every object moves with a constant speed. Speed is not constant. Speed may not be constant. So every object moves with a constant speed, this statement is incorrect. Write false, or you can write incorrect. Now 3. Distance between two cities is measured in kilometers. Kilometer, that is the unit used to measure length. The distance between two places should be measured using kilometer or mile. Miles or kilometer, these two units are normally used. So here your answer is true. This is true. This statement is correct. The time period of a given pendulum is not constant. The time period of a pendulum is constant. And you know that the motion of the hands, the spring of the pendulum shows periodic motion. What is periodic motion? The motion of any object at a regular interval of time is called periodic motion. So you can see the uh, motion of the spring in the pendulum is a constant. That means that repeats itself at a regular interval of time. So that is why the speed is constant. So here the statement is incorrect. Right, false. And the last one, the speed of a train is expressed in meter per hour. No, meter per hour, that is not the appropriate unit. Kilometer per hour. We express the motion of a train in the form of kilometer per hour. Okay, so you got your answer. Next, some what problems are given. You can see a simple pendulum. Question number 3. A simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? It is a periodic motion. So 32 seconds. 32 seconds is taken to complete 20 oscillations. Now you need to find out the time period of the pendulum. That means you need to find out the time or time period of one oscillation. So just divide 32 by 20. That means time by oscillation, the number of oscillation. Okay, so time is here, the time is 32 and 20, that is the number of oscillation. So here your answer would be 2 tens are 20, 2 16s are 32, 2 5s are 10, 2 8s are 16. So 8 by 5. 8 by 5. So just make it in fractional form, convert it in a fractional form. I mean, that is a fractional form. Point may layout 5 ones are 5, extra is 3, so 5 6 is 3, so 1.6. The time period of the pendulum is 1.6 second. 1.6 seconds. So what is the procedure? The procedure is just divide the number of oscillation, sorry, the time taken to complete 20 oscillations. So here the time is 32, so that should be divided by 20. You will get 1.6, and that will be the answer. Next, the distance between two stations is 240 kilometer. The distance is 240 kilometer. A train takes 4 hours to cover this distance. The total number of hours that is needed to cover the distance is 4. So calculate the speed of the train. So speed should be expressed, the speed of a train should be expressed in kilometer per hour. So we need to make the calculation and how to solve. How can we solve? The distance is 240 kilometer. That is the unit. Okay. The train takes 4 hours to cover the distance. 4 hours में the distance is already covered. So just divide 240 by 4. You'll get the speed of train. अगर 4 hours में 240 kilometers distance वो ट्रेन ने कवर किया है, तो 1 आवर में कितना होगा तुम्हें ढूंढना होगा. So we need to find out the distance covered by 1 hour. For this, just divide 240 by 4. You will get 60. So 60 kilometer per hour. That is the answer. Okay, so make the calculation. I hope that you can easily solve. Next, the odometer. The odometer of a car reads 57,321 kilometer. The reading is the primary reading. The first reading is 57,321 kilometer. When the clock shows the time 8:30. 8:30 में this is the reading 57,321. The odometer reading was changed to 57,336 kilometer, and the time, here the time not been given, so time is 8:50. So when the time is 8:30, the reading is 75,321, and when the time is 8:50, the second reading we are getting 57,336. Now calculate the speed of the car in kilometer per minute during this time, and express the speed in kilometer per hour. So we need to express the speed in both the forms, kilometer per minute, kilometer per hour. Okay, so first reading and second reading, these two are given. Two times been mentioned, 8:30 and 8:50. 8:50 is missing here. Okay, so just put the second time 8:50. So what is the difference between the distance and the time? First of all, we need to find out. So 57,321, that should be subtracted from the second reading. So second reading से first reading को तुम्हें subtract करना होगा, and you will get the distance. So what will be the distance? The distance will be 5:1. So 15 kilometer. So 15 kilometer, that is the difference between these two readings we got. Now the difference between the time 8:30 and 8:50. So 8:50 minus 8:30, 20 minutes we are getting. So 20 minutes, that is the difference of time, and the difference of distance is 15 kilometer. So 15 kilometer is covered by 20 minutes. 15 kilometer covered in 20 minutes. So here we need to find out the distance covered by the train in 1 minute. Sorry, by the car in 1 minute, not train. Let's erase this and then make the calculation. 15 minutes, that is the difference. So 15 minutes covered in 20 minutes. 15 kilometer covered in 20 minutes. So the distance covered in 1 minute should be 15 by 20. 15 by 20. 5, cut these two, both are divisible by 5. So 5 3s are 15, 5 4s are 30. So 3 by 4. So just convert 4 sevens are point 4 sevens are 28 and 4 fives are 20, so 75 point 75 0.75 kilometer per minute. So this is the distance, this is the speed of the car. 0.75 किलोमीटर पर मिनट, तो 1 मिनट में 0.75 किलोमीटर जाएगा, तो 1 घंटे में कितना जाएगा? You can multiply this number by 60, you'll get the answer 0.75 by 60, or you can multiply 3 by 4 into 60. So this is the time we need to express in kilometer per hour. Kilometer per minute में already we have converted, that is 0.75 kilometer or 3 by 4 kilometer. So to get the speed in kilometer per hour, this number should be multiplied by 60. So 1 मिनट में 3 by 4 किलोमीटर, तो 1 घंटे में कितना जाएगा? You know that there are 60 minutes in 1 hour. So 4, 15, 16, so 45 kilometer per hour. Okay, or you can multiply 0.75 by 60, you'll get the same number. Now 6, Salma takes 15 minutes from her house to reach her school on bicycle. If the bicycle has a speed 2 meter per second, calculate the distance between her house and school. So time taken by Salma is 15 minutes to reach her school, and the speed of bicycle is 2 meter per second. 2 meter per second, 1 second में 2 meter. So 15 minutes, this is the time taken by Salma. So here 1 second 2 meter, so 15 minutes, that is the time. So 15 minutes means how many seconds? Just convert 15 into 60. Clear? 15 minutes should be converted into seconds. And how to convert minute into seconds? Just multiply 15 by 60. You'll get your answer. And then just divide the number. Not divide. 1 second में 2 meter. So that second, just multiply. So 2 into 15 into 60 equal to 2 15s are 30, 36, 3 6 are 18, 0 0, 30 and 60. Okay, 1800 meter, 1800 meter. So इतना distance होगा 1800 meter, or you can write 1.8 kilometer. If you convert 1800 meter into kilometer, then you will get 1.8 kilometer. So 1.8 kilometer, that is the distance between the from the school of from the house of Salma to the school. So the distance between her house to school is 1.8 kilometer. Now 7, show the shape of the distance time graph for the motion of falling car, a car moving with a constant speed. Suppose the shape, the time and distance graph should be shown. So here just make this line, 2 lines, one is horizontal, another is vertical. This is vertical line. So this is the speed, this is time, this is speed. So S for P, speed, okay, and T for time. So the fast car is moving with a constant speed. This constant speed, that means कांस्टेंट स्पीड में वो कार मूव कर रहा है तो कांस्टेंट होगा. तो यहाँ पर अगर चेंज होता है एक कार पार्क्ड ऑन द साइड ऑन ए साइड रोड, ऐसा होगा. ऐसा होगा. जितना टाइम बढ़ेगा स्पीड भी, सॉरी, दैट इज नॉट स्पीड, डिस्टेंस. ओके, that is distance, and d for distance and t for time. The distance and time, these two relation can be expressed in the graph, time distance graph. So when the car with a constant speed, then the line will be like that. Okay, if time increases, distance will also increase. The car parked on a side road, parked, so no time, no distance. Clear? This is the graph. Just remember, just keep it in your mind. Now 8, which of the following relation is correct? Yes, speed equal to distance into time. That is correct or incorrect? No, the relation between distance and time is distance d equal to speed into time. Okay, so speed equal to d, that means distance covered, by time taken. So d by t, speed equal to d by t, distance that is covered and the time that is taken by the particular object, car, train, whatever. Okay, so this, that is the relation. Okay, that's all. So solve all these problems. If there is any question, then you can ask me. Thank you.